Alright, this is the third and final part of our test on radical functions. In this video we will focus on transformations of radical functions and how those transformations appear in the functions. So looking at number 12, we're supposed to use the description to write the square root function that is reflected across the x-axis, translated 10 units up and 9 units to the right. So let's see. Alright, so a square root function that's reflected across the x-axis. Now that shows up as a negative sign in the front when it's reflected across the x-axis. So then we'll have the square root. Alright, now the 9 units to the right, that happens on the inside of the function. Now it should be the opposite of the way it looks, so to the right will actually be minus 9. So this would be 9 units to the right. Now 10 units up, we'll have to put a plus 10 on the outside of the radical, and that would be 10 units up. So that is number 12. Let me make this a little bigger. Alright, so number 13. Again, we're supposed to create a square root function, but this time we're given the domain and the range. Okay, so the domain being 4 to infinity. The parent function for a square root function starts out like this with it starts out at 0, 0. So this would be the parent function. So if it's going to have a domain of 4 to infinity, that means it would have to be shifted over to the right by 4. Okay, so it'd have to be over to the right 4 so that the domain could become 4 to infinity. So the key is looking at this and understanding that this represents a shift to the right by 4. Okay, so when we begin to write that equation, okay, so that's f of x equals, alright, so if it's to the right by 4, then that's going to mean x minus 4. Okay, just like on problem number 12, 9 units to the right, we had to do x minus 9. 4 units to the right would be x minus 4 on the inside. Now, how about that range? What's going on with the range? So for the range to be negative infinity to 2, alright, so 2 things have to happen. So, this was not the actual graph. I was just focusing on the 4 to infinity part. This won't be the actual graph either, but I'm just going to focus on the range here. If the range is negative infinity to 2, the only way that could happen, first of all, 2 now has to be the highest value on this graph. Okay, so it has to be up here at 2, so negative infinity to 2. So it has to be coming up from the bottom and then to 2. Okay, so it has to be doing this type of a thing. Okay, if it would go from negative infinity to 2, negative infinity to 2. So that means 2 things. You see how compared to the parent function, which curves upward, this is curving downward. So that means there's been a reflection over the x-axis that happened. Okay, so let's talk about that. It's upside down, so that means we're going to need a negative in front to capture that. But then also it's been shifted up 2. So we're going to need that plus 2 on the end to capture that. Alright, of course, if I put both of these things together into one graph, okay, to where it's shifted over to the right 4, and it's up 2, and it's upside down, okay, that would actually look more like this. Alright, it's got to be to the right 4. If I put that all into one nice graph, that would look like this. Alright, so it's to the right 4, but it's also up 2. So that would be like here, and it's upside down. Okay, so this is what it would actually look like. But here's the equation.
Alright, in number 14 we are asked to describe the transformations. The negative sign is going to be a reflection over the x-axis. Alright, now the 3, sort of ignoring the negative sign, just looking at the 3, this is going to be a vertical stretch. By a factor of 3. Now, anything inside the radical is going to be a horizontal something. But it's going to be the opposite of what it looks like. So this will actually be a horizontal compression. By a factor of 1/2. Okay, now this plus 1 is going to be a horizontal motion, and it will be left 1. Alright, again, anything in here will be the opposite of what it looks like. This -1 on the end will send the graph down 1. Okay, so 5 transformations.